Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. So as the strength is 30 only, we will wait for another 2-3 minutes and then we can start with our lecture. Okay, whether the screen is visible? Yes, students. The screen is visible to you?
Yes, ma'am.
Okay. So let us start with the lecture. Why the strength is so less? Right now also only 72 participants are there. Is there any other activity going on? Class or lecture? Or extra session? Like, okay. So let us start with the lecture. So today we are going to start with our unit number 5. The name of the unit is Visible Lines and Visible Surfaces. And as the name suggests, we are going to find out the visible lines and visible surfaces. So what do you think? What can be the benefit of it, or why it is needed to find out these visible lines and surfaces? Can you guess any utilization or application of finding out the visible lines and visible surfaces? Can you guess any of the application or use? Or just can you elaborate what is visible lines? Okay. So see here, visible lines or visible surfaces. The name suggests visible means that we can view, right? Visible means that we can view. So visible lines means what? The lines on the screen which are visible to us. The lines on the screen which are visible that we can view them. So such lines and surfaces we have to find out, right? So it is also called as visible surface detection, VSD. Visible surface detection. Okay. The meaning is, if on the screen, this is your screen, and I want to display some objects on it. I want to display some objects on it. For example, I want to display a cone. Then I am interested to display one cylinder. Okay, right? Now, whenever I am drawing these two figures, what do you understand? This cone shape is completely visible, while the portion of the cylinder is, some portion is missing because it is present behind this cone. Because it is present behind this cone. So a portion of this cylinder is missing. If I am drawing the whole lines or complete lines, whenever I am drawing the complete lines, now whether it is, if I am watching this particular picture, is it clear to you that whether the cone is in front or the cylinder is in front? आता तुम्हाला हे पिक्चर बघून कळतंय का की कोण पुढे आहे का सिलेंडर पुढे? No, you cannot get it because I am focusing on multiple objects on the display. या डिस्प्लेवरती मल्टिपल ऑब्जेक्ट्स आहेत आणि दे आर ओव्हरलॅपिंग टू इच अदर. याला काय म्हणतात? दे आर ओव्हरलॅपिंग टू इच अदर. मग या केसमध्ये मला हे माहिती नाहीये की कोण विजिबल आहे, कोण वेदर कोण इज इन फ्रंट ऍज पर माय व्ह्यू. मी इकडून बघतीये. सो आय कॅन से द कोन इज इन फ्रंट. So I can remove the portion of the cylinder which is invisible. So I am removing this portion of the cylinder as I am viewing from this side. If I am viewing the object from back side, then what will happen? Exactly opposite is the case. I have to focus on the cylinder and I will remove the portion of the cone as it will be invisible with respect to the view or with respect to the viewer. Okay, so if I am concentrating on the direction of view or the viewer, then the objects will be viewed differently. मग त्यांचे विजिबल लाईन्स त्या ऑब्जेक्टच्या आणि विजिबल सर्फेसेस विल बी डिफरंट इफ आय एम चेंजिंग द डायरेक्शन ऑफ व्ह्यू. जेव्हा मी व्ह्यूची डायरेक्शन चेंज करतेय तेव्हा डेफिनेटली दिसणारे लाईन्स आणि सरफेस सुद्धा चेंज होणार आहेत. इकडून बघितलं तर मला कोण पुढे दिसतोय आणि सिलेंडर पाठीमागे, पण मी ऑपोजिट डिरेक्शननी बघितलं तर मला होल सिलेंडर दिसेल विच विल बी इन फ्रंट आणि कोण बॅक साइडला दिसेल. सो आय हॅव टू कॉन्सन्ट्रेट ऑन द विजिबल सर्फेसेस with respect to a particular view. I have to concentrate on the lines and surfaces which are visible with respect to the viewer. ज्या साइडला व्ह्यूअर आहे त्याप्रमाणे तुम्हाला विजिबल लाईन्स आणि विजिबल सर्फेसेस हे चेंज होणार आहेत. बरोबर आहे. म्हणूनच सो in order to show the hidden portion, what we are doing, we are showing it in a dotted line or we are simply discarding them. Hidden lines, hidden surfaces and hidden lines मला जर दाखवायचे असतील तर मी काय करते, either I will show it with the dotted lines. So if I will show here the dotted line, if I will show this with dotted line, it means this portion is hidden and that can be removed. हा पोर्शन हिडन आहे आणि आता मला जेव्हा मी हे स्क्रीनवर डिस्प्ले करते तेव्हा या हिडन पोर्शनचा काही उपयोग आहे का? नाहीये, बिकॉज आय एम नॉट गोइंग टू ड्रॉ धिस शेप, दिस पार्ट और दिस पोर्शन ऑफ द सिलेंडर सेपरेटली. मी ह्याचा या सिलेंडरचा हा पोर्शन मी सेपरेटली ड्रॉ नाही करणार आहे. सो इट इज ऑफ नो यूज विथ रिस्पेक्ट टू द डिस्प्ले of that object on the screen, and that is called as hidden surface removal. It is also called as visible surface detection, or it is also called as hidden surface removal, HSR. Now, why it is required to remove such hidden portions? Can you guess? What can be the benefit of removing such portions? Yes. काय उपयोग आहे मला हे hidden portions remove करून?
To avoid confusion between two surfaces.
Yes, it can be there. Like if the surfaces are overlapping, then with respect to viewer, which image is in front or which object is in front and which is at back, you can classify or we can separate out. That is one use. And the second important use is in case of memory requirement. Because जेव्हा मी हे डिस्प्ले करते आउटपुट स्क्रीनवर, सो इट रिक्वायर्स सम मेमरी इन द फ्रेम बफर. जे काही मला ऑब्जेक्ट डिस्प्ले करायचे ते काय होतात, त्याचे सगळे पिक्सेल वाईज इन्फॉर्मेशन ही फ्रेम बफर मध्ये तुमची स्टोअर असते. बरोबर. We have seen this in frame buffer. The information about every pixel of this cone. Similarly, the information about every pixel of the cylinder is stored. So I will write cylinder and cone. समजा या कोन मध्ये 100 पिक्सेल असतील तर it is having the information about all those 100 pixels. And here in the cylinder, if I am having total 150 pixels, then in the frame buffer, it is having the information about all those 150 pixels. In that, you can have the XY coordinate of that pixel, then color of that pixel, and many other things like intensity of the pixel, color, and all those things, right? So I have to fetch all this information from the memory to the frame buffer. मग आता काय होतंय, हे पिक्सेल्स मला प्रिंट करायचे किंवा I have to draw those pixels on the screen. I have to display on all those pixels. Out of that, this portion is not of use, so I can remove those number of pixels from the frame buffer because frame buffer holds the data which I want to display. Frame buffer मध्ये काय? The data which I want to display. But if this portion of the cone is not going to display, we are not going to display this, then we can remove that from the frame buffer. So now if cylinder total is having suppose 150 pixels, out of that these 25 pixels are of no use, then instead of fetching total 150 pixels data, I can fetch only required 125 pixels data from the memory into frame buffer for display purpose. So it efficiently uses the memory for displaying the objects. Okay, so that is the main use of detecting or finding out the visible surfaces and visible lines. So in this way, we can have the clear concept about the objects. And the second is we can efficiently use the memory by detecting the visible surfaces and visible lines. Okay, so that is about the title of the chapter. Now in that we are going to learn what is hidden surface. So just now I have told you what is hidden surface, the introductory part of visible lines and visible surfaces. And then we are going to have the algorithms to remove such hidden portions. So which are those algorithms? So first algorithm is backface removal algorithm. So the name itself gives you idea, backside face of the object that gets removed with the algorithm. So backface removal algorithm, Painter's algorithm, then Warnock algorithm, Z-buffer algorithm. So these are the 4 points we are going to learn for visible surface removal or visible surface detection or hidden surface removal. Then we are going to concentrate on 2 techniques which are called as anti-aliasing and half-toning. So there are 2 techniques, why they are required and where is the application of these 2 methods that we will see in detail. So in the chapter, total 4 algorithms are there: backface removal, Painter's algorithm, Warnock algorithm, and Z-buffer algorithm to remove the hidden lines and hidden surfaces. And 2 approaches or 2 techniques we are going to study. They are anti-aliasing methods and half-toning methods. Okay. So let us start with the chapter. So visible lines and surfaces, or it is also called as hidden surface removal. So how to detect? So I can say here visible lines and surface detection. or it is also called as hidden surface removal. So either we can detect the portions which are visible, or we can eliminate the portion they are hidden. Now we will see in detail. In 3D computer graphics, hidden surface determination, that is HSD or HSR removal, is also known as hidden surface removal, HSR, or it is also called as occlusion culling. Occlusion means what? Overlapping. So removing the overlapping is nothing but occlusion culling. Occlusion means one object is occlusing other, means it is present in front of the other object. So they are overlapping in nature. So occlusion culling, it is also called as overlapping removal or visible surface determination. So this visible surface detection is also called as hidden surface removal, HSR, or hidden surface determination, HSD, or OC, that is occlusion culling. This process is used to determine which surfaces and part of the surfaces are not visible from a certain viewpoint. So this is very important, because we have seen with respect to the viewer, or the angle or the direction of viewer, your portion which is visible and which is hidden changes. Eka direction ni आपल्याला वाटतं की this portion is visible, and if I am viewing from the opposite direction, then that portion becomes hidden. So this detection of visible lines or hidden portion removal is totally dependent upon the viewpoint. Given a set of 3D objects and a viewing specification, we wish to determine which lines or surfaces are visible. So we have seen in earlier example, given a set of 3D objects. So आपण दोन object consider केले होते, एक cone and एक cylinder, and viewing specification. So viewing direction we have already considered. We wish to determine which lines or surfaces are visible. So we wish to determine which portion is visible, so that we do not unnecessarily calculate and draw surfaces which will not ultimately be seen by the viewer. So why to detect these visible lines or surfaces? Because we don't want to unnecessarily do the calculation and draw the surfaces which ultimately are not visible. जे अल्टिमेटली विजिबल नाहीच आहेत स्क्रीनवरती, ते आपण अननेसेसरी कॅल्क्युलेट पण करत बसतो आणि ड्रॉ करत बसतो. सो unnecessary action of drawing and calculation will be saved. So the portion which is ultimately non viewable, or it is not seen by the viewer, that can be removed, or which might confuse the viewer. आपण बघितलं होतं, if I am drawing the objects, then it creates the confusion which object is in the front and which object is at the back. So that creates the confusion. Okay, so we need to have the visible surface detection. The various algorithms are referred to as visible surface detection methods. So we have different algorithms. We are going to see those algorithms in our coming lectures. Next is, sometimes these methods are also referred to as hidden surface elimination methods. It is one and the same thing. We are finding out the visible surfaces, means at the same time we are removing the hidden surfaces. आपण visible find out करतोय म्हणजेच काय, जे hidden आहेत ते आपण remove करतोय. Although there can be differences between identifying visible surfaces and eliminating hidden surfaces. So we can have the differences between these two methods. It is nothing but simply identifying the visible portions and eliminating the hidden surfaces. Then we may not want to actually eliminate the hidden surfaces, but rather to display them with dashed boundaries to retain information about their shape. So actually आपण hidden line हे remove करतोय पण ते frame buffer मधून करतो. But if I want to, if I'm not eliminating such hidden portions, then instead of drawing the complete line, or we can say the solid line, instead of that, we can make use of dashed line to indicate that those portions are hidden. Right? We have to, instead of directly eliminating the hidden surfaces, instead of actually eliminating the hidden surfaces, we are displaying them with dashed boundaries. We are displaying those things with dashed boundaries, which will retain the information about their shape. What is the need of drawing those dashed boundaries? So that we can come to know about the actual shape. In 3D objects, we should know the actual shape of the object, and that's why the dashed boundaries are required to retain the shape of the object. And at the same time, the dashed line indicates those surfaces are hidden in nature. So let us see the diagram of it. Yes. So you can see the diagram. So when all sides are drawn, that is solid lines are there. When all sides are drawn, that is solid lines. So we cannot determine which faces are visible with respect to user and which are hidden. Which are visible and which are hidden. That means which is front face and which is rear face of the cube. हा क्यूब बघून आपल्याला कळत नाहीये की which portion is hidden and which is visible. So our job is either we can draw it like this. So which is showing you, if I am viewing the object from this direction, then it can be seen that this portion is visible, this is visible, and this is visible. If I am viewing the object from this side, so I can do like this. I can draw the shape of the object like this. Which is actually hiding, or which is actually removing the hidden portions, or I am able to display only the visible surfaces with respect to this viewpoint, that is the direction of the viewer. Or I can do as just now we have seen that. Okay. Or I can do in second way, that is, this is directly removing the portions. Or so if I am removing these portions, I'm not knowing what is the actual shape of the object. I'm not knowing what is the actual shape of the object. It is just removing the edges or the surfaces which are hidden in nature. With respect to the viewer, the faces or the surfaces which are hidden, we are simply removing them. But now when I get this image, I am not able to judge the shape of this object. So the shape of the object is retained if I am showing the hidden surfaces with the help of dotted lines. So second thing is what? instead of directly removing the hidden surfaces, the alternative is I can draw the dotted lines. So now from this second diagram, it is more clear that this is the object, 3D object, and the type of the object is a cube. So I can have the cube. So this is the 3D box like structure. But from this diagram, as the total removal of the hidden surface is carried out, we cannot determine the actual shape. And to retain that shape, instead of removing the lines, we can replace, we can say that replacement of the line by solid line by dotted line will also give you the separation between the visible surfaces and hidden surfaces. Okay, all of you are getting up to this?
Yes, ma'am.
Yeah, okay. Okay, so in order to retain the shapes, we are simply converting the solid lines into dotted lines, and that also gives you the kind of visible surface separation from the hidden surfaces. Okay. So next is, in order to find out the visible portions or visible surfaces, there are two approaches. If I want to find out the visible portions or visible surfaces, it can be done in two ways. First method is called as object space method. First method is called as object space method. It works on actual physical coordinates. It works on actual physical coordinates, and that's why it is called as physical coordinate system. And the second method is called as image space. So name itself gives you idea. Object means the actual object space, and that's why physical coordinates are considered. And here the image space means its display is only considered, and that is done with the help of screen coordinates. And that's why this system is called as screen coordinate system. So there are two approaches to find out the visible surfaces. First is object space, which is physical coordinate system, and second is image space, which is screen coordinate system. So again, we can see the diagram of those. Yes. So the object space method. Yes. So this object space method it compares the objects and part of the object to each other. So what it is doing, it is comparing the object and the portion of that object. So part by part, that is line by line. Suppose this is a triangle and one rectangle, A and B, two objects are there. So it is comparing the line by line. So portion by portion. So it will compare one line of triangle A, whether it is visible or hidden kind of thing. So it will compare like that. So in object space method, it compare the object and part of the object to each other within the scene definition to determine which surfaces as a whole we should label as visible. And then it will determine which portion or which surfaces are considered as visible and which are considered as hidden. So these two are the objects or the cases where the objects are overlapping, right? So here the objects are overlapping or occluding or obscuring. So portion of A is on the back side. Here the portion of A is at the front side, and that is why we are having the partially obscuring or partially overlapping objects. So partially overlapping is one example, and second is when the objects are not overlapping, then we can draw them independently. We can draw them independently. So there we don't have to go for this object space detection or visible surface detection. So for this partially obscuring method, we are having the object space method where we can apply the phenomena like vector and normal method. Similarly, we can have the inside outside test and all. So we are going to see the example of this object space method is backface removal algorithm. So first algorithm that we are going to study is under this object space method. So in object space method, we are checking the portion or line by line of the object, and for partially overlapping objects, we are applying the algorithm, and the name of the algorithm is backface removal. The second is the image space method. So image space method or this algorithm is or in this method, the two algorithms we are going to learn. One is called as Z buffer algorithm or depth buffer algorithm, and the second is called as area subdivision algorithm. So in this image space type of approach, the two algorithms we are going to study. So here in an image space algorithm, visibility is decided point by point at each pixel position on the projection plane. So it is going to decide point by point display. In earlier method, what we have seen, the portion by portion or part by part. So it is actually checking for the overlapping part in the object space. And here the point by point display is considered. For example, here 1 pixel is considered, which is called as COP, center of pixel. So here COP is considered. Now that pixel, on that pixel, it will check how many, excuse me, it will check how many objects are actually overlapping at that pixel. Right? How many objects are overlapping? What is the meaning of it? This is your screen. If I'm having a rectangle, on the same rectangle, I'm having one kite or I'm having one circle. It is overlapping on it. And on the same, I'm having one triangle. So triangle is in the front with respect to the viewer. So if I consider this center object, it is represented with a black dot. If I am considering this central pixel, then earlier when I was drawing the rectangle, that pixel is of rectangle color. I can say that this pixel is a part of rectangle. When the circle is overlapping it, त्याच्यानंतर मी सर्कल ड्रॉ केलं, मग आता काय होतंय, तो पॉइंट ऑफ रेक्टँगल is going at the back and the same pixel is acting as a part of circle now. आता मी त्याच्यावरच सर्कल ड्रॉ केलं, मग मी काय करणार आहे, समजा रेक्टँगलला ब्लू कलर असेल, आय विल गिव्ह द कलर. Suppose this rectangle is of blue color. जेव्हा मी रेक्टँगल काढला तेव्हा हा पिक्सेल असेल तो ब्लू कलरचा असेल. ओके, त्याच्यानंतर आलं त्याच्यावर सर्कल. इफ सर्कल इज ऑफ रेड कलर, तेव्हा काय होईल, तो ओव्हरलॅपिंग पिक्सेल असल्यामुळे तो आता मला रेड कलर मध्ये कलर करावा लागेल, कारण सर्कलचा कलर रेड आहे. बरोबर. आणि आता त्याच्यावर जर ट्रायंगल असेल, तर as triangle is in the front and triangle is having the black color, so now this pixel is of black color. So what I am checking? I am checking pixel by pixel information of the overlapping objects. Okay, all of you are getting this? Earlier method मध्ये काय होतं, portion wise आपण check करत होतो की which portion is overlapping. Directly we are discarding them or we are making it hidden or visible. And in this case, now every pixel visibility is checked by every pixel in the projection plane. Projection plane is nothing but the viewing projection, the direction of the viewer. Okay, so what it will do, what is the pseudocode for it? For every pixel in the frame buffer, आता frame buffer मध्ये मी काय display करणार आहे, असं picture which is overlapping in nature. The picture which is overlapping in nature, म्हणजे ब्लॅक कलरचा ट्रायंगल तुम्हाला पूर्ण विजिबल असेल, त्याच्या पाठीमागे रेड कलरचं सर्कल, हे ट्रायंगल इज ओव्हरलॅपिंग ऑन दॅट सर्कल, आणि त्याच्या पाठीमागे तुम्हाला ब्लू कलरचा रेक्टँगल असेल, जेवढा दिसेल तेवढा. राईट. सो आय एम ऍक्च्युअली डिस्प्लेइंग दिस इमेज, आणि ही इमेज डिस्प्ले करताना काय करायचंय, फॉर एव्हरी पिक्सेल इन द फ्रेम बफर I have to determine which polygon is closest to the viewer. कुठला पॉलिगॉन ह्याचा व्ह्युअरच्या क्लोजेस्ट असेल, मग ह्याच्यामध्ये ट्रायंगल व्ह्युअरच्या क्लोजेस्ट आहे. सो इट विल कलर द पर्टिक्युलर पिक्सेल विथ रिस्पेक्ट टू द ट्रायंगल कलर. मग प्रत्येक पिक्सेल तो चेक करणार, तो ट्रायंगलच्या मध्ये आहे का, येस, देन इट विल कलर इट विथ ब्लॅक. देन द सराउंडिंग पिक्सेल्स विच कम्स इन circle, it will be colored as red, and then the outer portion which is visible with respect to the rectangle, it will be colored as blue. Okay, so the closest polygon we have to consider that pixel location as visible. Color the pixel with the color of that polygon. So I am going to color it with black color. Then surrounding is with red color and the rectangle which is outside with blue color. हे मी डिस्प्ले करणार आहे. सो इट विल ऑटोमॅटिकली रिमूव्ह द पोर्शन्स. या पिक्चर मध्ये तुम्हाला दिसेलच, इट विल ऑटोमॅटिकली रिमूव्ह द पोर्शन. आता तुम्ही इथं युजर विथ रिस्पेक्ट टू द युजर, दिस इज द डायरेक्शन, and I can see that the triangle is closest with respect to the user, then this rectangle, and then this last diagram, whatever it may be. So I am able to see the diagram like this. Okay, getting it? Yes, students. So two approaches are there. One is portion by portion detection of hidden and visible surfaces, and other is point by point detection of visible surfaces and hidden surfaces. Is there any difficulty up to this? इथपर्यंत काही नाही कळलं असं आहे का? येस, रिप्लाय स्टुडंट्स. कळले सगळ्यांना इथपर्यंत?
Yes, ma'am.
Okay. Girls?
Yes,
Yes,
ma'am.
ma'am.
Okay, thank you. So let us move to the next bits. So now we will see the algorithms in detail. So two approaches we have studied. We have studied what is visible lines, what is hidden surface removal, then the definitions of them, and the two approaches, object space method and image space method. So we will see in detail the algorithms. Okay. So the first algorithm, it is called as backface removal algorithm. So the name itself gives you idea, backface. The face, that is nothing but the surface which is at the back side with respect to the viewpoint, is detected. So we are detecting the backside faces or backside surfaces of the object. This method is very fast and simple method, right? This method is very fast and simple, and it comes under the object space method. First approach, object space method. Okay. So how the detection is carried out, that we will learn now. So it is a very fast and simple object space method for identifying the back faces of the polyhedron, is based on inside outside test. So it is based on inside outside tests. So for any polygon surfaces, the point is lying inside. एक point आहे जो inside a point with XYZ. It is a 3D object, polyhedron. So it is a polyhedron which is 3D in nature. So how you are going to check whether the particular pixel is inside the polyhedron or outside the polyhedron? So a test is carried out with a point XYZ are the coordinates of that point. XYZ are the coordinates. A point XYZ is inside a polygon with plane parameters A, B, C, D. So these are the constant coefficients. If when an inside point is along the line of sight to the surface, the polygon must be back face. In short, I can say that suppose A, B, C, D are the four coefficient coordinates and X, Y, Z are the points, then I can say that AX plus BY plus CZ plus D. This is the equation of the point which is lying inside the polygon. So if it is inside, when this expression is greater than equal to 0. So the expression for the point which is inside the polygon, so this is the expression for it. And I can say AX plus BY plus CZ plus D is greater than equal to 0. If this is the condition, then only we are going to see that the point, that particular point is inside. Okay. So here that AX plus BY plus CZ, if we are going to put the point coordinate as let us say okay, so before going deep into this, we will read these things where what is the normal and how to determine whether the normal is pointing towards user or it is pointing away from the user. So if the normal of the particular face or surface is pointing towards the user, then that face is considered as visible, or that surface is called as visible surface. And when the normal is pointing away from the user, then that face is considered as invisible, or we can say that hidden. So here When an inside point is along the line of sight to the surface, the polygon must be back face. We are inside that face and cannot see the front of it from our viewing position. Then we can simply do this test with the normal vector n and a polygon surface. So here, which is the Cartesian component of ABC in general, if V is a vector in the viewing direction from the eye or camera position, then the polygon is a back face if V dot n is greater than 0. So here, consider the surface. One more test with respect to back face detection is we are going to denote the edges of the surface in anti-clockwise manner. Suppose these are the 4 edges and viewer is viewing from this side. Then we are going to denote it in the anti-clockwise manner. So whenever I am drawing the edges and showing the direction as anti-clockwise, then that particular edge or that particular face is pointing its normal towards user side. Then it is pointing the normal towards user side. So I can say that the normal of this face is pointing user side when the direction of movement of the edges are in anti-clockwise manner. Then what can be the hidden? If you are viewing from this direction, what will be the direction of movement of these edges? इकडून बघितल्यानंतर आपल्याला अँटी क्लॉकवाइज दिसतंय, पण if the viewing direction is from this side, then the direction of these edges appears to be in clockwise direction. इकडून बघितल्यानंतर काय दिसणार आहे तुम्हाला? हे क्लॉकवाइज मूव्ह होतंय हे दिसणार आहे तुम्हाला. बरोबर आहे ना? So if viewer is viewing this, then it is observing the anti-clockwise movement of the surface edges. And in the opposite direction, if viewer is viewing from this edge, then it is observing it is in the clockwise manner. So when the edges are in clockwise manner, it is considered as a hidden portion and the normal is moving away from those edges, right? So here the normal is coming towards the viewer if viewing direction is this. At the same time, the viewing direction is opposite, that is in clockwise manner, and the normal is moving away from this viewer now. So it is always said that when the normal vector n is tested, and if that vector is pointing towards the viewer. So in general, if V is the vector in the viewing direction from the eye or camera, then that normal into viewing vector, if it is greater than 0, then that portion is considered as back face. That face is considered as back face. So here the normal is towards the viewer only. And the example here I can show you. 1 second, I will show you the diagram. Okay. Is it visible? Yes. So in this particular diagram, you can see viewing direction or camera direction is on this side, and the normal is moving away from the viewing direction, so that that face becomes invisible or hidden with respect to the view. So here is the another example in which the hidden portions, in which the normal of that particular surface is moving away from the user side. And that's why this face and the normal which is moving away, so 1, 2, 3, 4, and 5, so these 5 faces becomes hidden from the user side, and in the viewing direction only 1, 2, 3, and these 3, they will become the visible portions. So whenever these are the hidden portions in which the normal is pointing away from the user, then we can remove those surfaces, and so that the memory requirement for those surfaces will be minimized. Okay, so that is how a normal is calculated with respect to every face or surface of the polyhedron. And then if that normal is pointing away from the user, then those surfaces are considered as back faces. And when the normal is facing towards the user, then those surfaces are considered as visible faces. Okay, so we will see the calculation or the mathematical module of this backface removal algorithm in the next lecture. So as the time is up, we will stop here for today, and we will see this backface removal algorithms remaining portion plus remaining Z buffer algorithm and Warnock algorithm in detail in the coming lectures. Okay, so thank you. We will stop here now. No need to give the attendance because I'm having your attendance in the Excel sheet getting generated by Zoom. So actually it is not required to mention your attendance over here. So I'm ending the meeting for all. Thank you.